Have you ever wondered how a website, hosted literally halfway across the world, can just pop up on your screen in a split second? Well, it's not magic, I promise you. It's something called a Content Delivery Network, or CDN. So today, we're going to do a visual walkthrough of how these things work and how they make the internet feel so incredibly fast.
All right, here's what we're going to cover. First, we have to talk about the biggest problem of all, distance. Then we'll get into the solution, the CDN itself. We'll follow a user's very first request to see what happens, and then dig into the clever way your browser finds the closest server. After that, we'll get into the nitty-gritty rules of caching. And finally, we'll zoom out and see how a CDN fits into the whole system.
Okay, so first things first, we have to understand the fundamental challenge here. We talk about the cloud, but the internet isn't some magical ether. It's real. It's physical wires and servers. And that means when you're talking about speed, geography is absolutely everything. So, let's do a little thought experiment. Picture a world map in your head, okay? Now, put a big dot right in California. That's our origin server. Think of it as the main library, the headquarters. It's holding the one true master copy of our website, all the images, all the code, the whole shebang.
Okay, got your dot in California? Now let's put another one all the way on the other side of the map, in Tokyo. That's our user. Now, for that person in Tokyo to see our website, a request has to travel all the way from Tokyo to California, and then all the data has to travel all the way back. That round trip, even at the speed of light, takes time. And that delay is what we call latency.
So, how do we fix this? I mean, we can't exactly shrink the planet, right? But what we can do is make the trip for the data much, much shorter. And that is exactly where the CDN comes in. It's basically a huge global network of servers whose only job is to store copies of content way closer to you, the user. This here really shows you the problem perfectly. See that long arrow? That's our user in Tokyo. They make a request, and it has to go all the way to the origin server back in California. That trip takes about 120 milliseconds. Now, you might be thinking, 120 milliseconds, that's nothing. But here's the thing, modern websites are made of hundreds of files, and all those little delays, they add up fast. And suddenly, your website feels really, really slow. So what's the big payoff for using a CDN? Is it a tiny little improvement? No way. We are talking about a massive speed boost. Like, in this case, a whole 3 times faster. And here's how it works. Let's go back to our mental map. The CDN puts a server, we call it an edge server, right there in Tokyo. Now look at the arrow. It's so much shorter, right? The user's request just goes to that local server. The whole round trip is now a blazing fast 40 milliseconds. It's the difference between a short hop across town and a full-blown trans-Pacific flight.
But, and this is a really important but, that server in Tokyo doesn't just magically have the files. It has to get them from the origin server first. This whole process means that the very first user has a totally different experience than everyone who comes after. Let's talk about what we call a cache miss versus a cache hit.
Okay, so let's trace the journey of just one single file, say an image. Over on the right, that's our origin server. In the middle, you've got the CDN. And on the left, we have 2 different people, user A and user B. They both want the exact same image.
All right, let's follow user A. They ask the local CDN for image.png. The CDN looks in its storage and it's not there. This is what we call a cache miss. So the CDN has to take that long trip for them. It goes and asks the origin server in California for the file. The origin sends it back, and now the CDN does 2 super important things. First, it sends the image to user A, but second, and this is the magic part, it saves a copy for itself.
Okay, so a few minutes later, user B comes along and asks for that exact same image. This time, when the CDN checks its storage, aha, it's there. That is a cache hit. The image is sent directly from that nearby Tokyo server, and for user B, the load time is practically instant. Boom! That's the power of the CDN.
So, that's the what. But what about the how? I mean, how in the world does your browser, sitting there in Tokyo, know to ask the server in Tokyo instead of the one in California? Well, the answer is this really clever multi-step dance that involves the Internet's phone book, the Domain Name System, or DNS.
Now, this diagram might look a little complicated at first, but don't worry, we'll walk through it. Let's say we have Bob, and he's in New York. He wants to visit a website that's hosted all the way over in London. But thankfully, there's a CDN in the middle. So let's follow what his browser actually does.
Okay, so this is what I call the DNS dance. Bob types in www.myshop.com. His request goes to a DNS resolver. That resolver goes and finds the website's main name server. But here's the trick. Instead of getting the IP address for the server in London, it gets an alias, a little note that says, hey, go talk to the CDN instead. So the resolver then asks the CDN's name server. That points it to a CDN load balancer. Now, this load balancer, this is the real brains of the outfit. It looks at the request, sees Bob is in New York, and it picks the best closest server for him. The reason for all these steps? It's all about intercepting the request before your browser ever learns about that faraway London server. The CDN cleverly substitutes the New York server's address instead, and Bob has no idea. It's all completely seamless.
But wait, what happens if that New York Edge server doesn't have the file Bob wants? Well, think of it like a library system. Your tiny local branch, that's the Edge server, doesn't have the book you want. Do they send you straight to the publisher in London? No, of course not. They first check with the big city library. That's the regional server. And if it's not there, they might check the national library, the central server. It's only after checking all these bigger, closer caches that they finally go all the way back to the publisher, which is our origin server. It's a really smart hierarchy that makes the whole system way more efficient.
Okay, so now we know how CDNs find the closest server and send you stuff. But what stuff should they be sending, and for how long should they keep it? This is where we get into the actual rules of caching.
So the most important rule is understanding the difference between static and dynamic content. CDNs are absolutely amazing for static things, images, CSS files, JavaScript, stuff that doesn't change very often. But they're a terrible idea for dynamic content, things like your personal user profile or your bank balance. That stuff changes all the time. You can't cache a live stock price, right? It would be wrong the second after you saved it.
And that brings up a really critical question, even for those static files. Okay, so you've cached an image. How long do you keep it? How long is it fresh before you need to go check for a new one? Should it be a day? A week? Maybe a whole year?
Well, the answer is controlled by something called time to live, or TTL for short. It's pretty simple, really. When the origin server first hands a file to the CDN, it attaches a little note, an HTTP header that's basically an expiration date. It tells the CDN, hey, hold on to this file for 1 hour, or keep this for 1 day. Once that time is up, the CDN knows it has to go back to the origin and ask for a fresh copy, just in case something changed.
Now, setting that TTL is a huge deal, but it's just one of the things you have to think about. For one, there's cost. You get charged for data transfer, so you probably don't want to cache everything, especially files that nobody ever looks at. Then there's the big one, invalidation. What happens if you update your company logo, but the TTL on the old one isn't up for another week? You can't have the old logo showing. So you need a way to force delete or invalidate that old file. You can usually do this through an API, or a common trick is to just change the file name a little, like adding v=2 at the end. And of course, you always need a backup plan. What if the CDN itself goes down? Your site should still work, right? It should be able to just get the files from the origin.
So up until now, we've been really zoomed in on just the CDN part. But in any real-world website, a CDN is just one piece of a much bigger puzzle that's all built for speed and reliability.
All right, let's take a look at the complete system. A user's request comes in, and the very first thing it hits is the CDN. You can see it there as number 1. The CDN immediately grabs all the requests for static stuff, images, CSS, all that. This alone takes a massive amount of work away from the main servers. Now the rest of the request, the dynamic part, keeps going through a load balancer to the actual web servers. Hey, look at number 2, the cache. Now this is a different kind of cache. This one's job is to speed up requests to the database for dynamic stuff. So you see how they work together? The CDN handles the static content on the outside, and this internal cache helps with the dynamic data on the inside. It's a 1-2 punch for performance.
And that really brings us to our final thought here. For, decades, the line has been super clear. CDNs are for static files, and origin servers are for the dynamic stuff. But as websites get more and more personalized, that line is getting really blurry. The next big challenge, the next frontier, is figuring out how to push not just content, but actual computation closer to the user, right out to those edge servers. So how are CDNs going to evolve to handle that? Well, that's the big question that's going to shape how fast the internet feels for all of us in the future.